Neo sweatshirt from the conference the other day, or last week rather. So this is going to be, I'm going to try to make this as compact yet as dense as possible. The actual contract that we're going to be writing for the example is going to be really simple, but I really just want to go over the basics of what a smart contract is, how it works, and just to show you how easy it can be to start developing your own contracts. So let me go ahead and exit out of all my unnecessary screens, and then I can hop into what's important. So let me sorry, I had a lot of stuff open. We had some technical difficulties before I started. Zoom and share screen. And we want to share the whole desktop. And all right, cool. All right. You guys can see, right? I think you can see. All right, now how do I minimize this? Oh, no, I don't. Okay. Awesome. All right, so to get started, I don't know if you guys are familiar. I'm going to assume you guys aren't familiar with NeoPython, NeoBoa, and private net or whatnot. So Neo is a very, it started off a very C#.NET heavy platform, but recently they've added more compilers for different languages, one of them being Python. So people in the Unix world can more easily get their hands dirty writing some of these smart contracts, and it uses Python 3. So what I went ahead and did, I'm a big VM guy, and I use Docker. So I went ahead and used one of my VMs, which already had Python 3 installed, and I went ahead and downloaded NeoPython and NeoBoa. Now, what are NeoPython and NeoBoa? NeoPython is the Python SDK for interacting. Sorry, this mouse is trash. Let me use this one. For interacting with smart contracts. So let me just go to it. So it's a full port of the original C# Neo project. So it's just a Python port of the C#. It allows you to run a Python-based P2P node, so you can write your consensus nodes and whatnot. It has interactive CLI for configuring node and inspecting blockchain. Let me go ahead and pull this chat up. Cool. Put that right there. Interactive CLI for configuring node and inspecting the blockchain. You can compile, test, deploy, and run smart contracts written in Python or any smart contract in the .avm format. It is compliant with NEP2 and NEP5 compliant wallets, and it is also an RPC client. So this is just part of it. So this is what's actually going to run the smart contracts, and then how we actually write the smart contracts would be using NeoBoa. So NeoBoa is the NeoBoa compiler is a tool for compiling Python files into the .avm format for usage in the Neo virtual machine. So let me take a step back and explain what the Neo virtual machine is. So all smart contracts are run on the Neo virtual machine. So if you're familiar with like the Java virtual machine or any other sort of virtual machine architecture, it's pretty much the same thing. So you take your code in your compiler, whether it's C# or you're doing Python or Go or what have you. You write your Python code and you run it through the NeoBoa compiler, because remember, Python itself is an interpreted language, but the NeoBoa is a compiler. So it turns your interpreted code and it compiles it into AVM bytecode. And I guess AVM was from when they used to be called ant shares. I don't know why they don't call it Neo virtual machine or NVM, but you know, whatever. So it turns your .py files, compiles them into .avm, and then you use NeoPython to actually deploy the smart contract. And then there is one last component, and where is it at? Oops, I exited it out. Let me what's it called? Meta Chris. Yeah. So we also have this Docker container because you know you gotta run on a test net or private net. So this is a Neo private net with gas. So you download this Docker container and you know, you get 100 million Neo, 6,000 gas. You got a ready to use wallet. So we can just get started building and deploying on our private network. The setup process to get all this installed is more difficult than actually writing the smart contracts, and it will kind of be tedious to try to go through that whole process right now. So what I will refer to you guys is go on YouTube. There are actually, yeah, I mean, if you just search Neo Smart Contract Python, there's only really like 5 good ones out there because you know it's pretty new. Their Python SDK is pretty new. So any of the videos on there will get you together. And it'll tell you how to set up the private net and all that. So let me just go over here to my terminal. Do I need to increase this size, or can you see the text? I'm going to go ahead and increase the size. Oops. All right. So this is, where am I at? Okay, so we're in the NeoPython right here. Freaking mouse. And this is the NeoBoa right here. All right, cool. So like I said, I've already gotten the private net set up with the Docker container. It's already connected. So when I run the prompt, I already have the synchronized blockchain in the wallet file. If you don't do that, then you have to, you know, pretty much wait and let the blockchain on the test net or private net or whichever one you're going to use reach the block height, and nobody's got time for that. So clear and ls. Cool. So right here I have a contracts file, and this is where I'm gonna, and this is inside the NeoPython folder. And basically what I did here is I you know, I followed the instructions on the NeoPython the NeoPython official website, and you can also get it from their GitHub, City of Zion, github.com/cityofzion/neo-python, and you'll have all the instructions on how to you know, get started and install everything. There's a lot of dependencies and stuff you got to install. Like I said, it took way more time in getting everything set up than actually getting started writing the smart contracts. And depending on what your architecture is, you have to jump through fiery hoops. But you know, that's new software for you. It'll get better over time. I'm sure they'll figure a way to better automate it. Where was I? So yeah, so I'm in, so you know, now I'm in the NeoPython. Let me switch into the contracts. So once you actually get NeoBoa and NeoPython set up, you can get started on writing your contracts. And these contracts are just simple Python files. You have to include the libraries, of course. Let me go ahead and just, yeah, test contract.py. You see right here, I got my contract.avm. This is the contract that I've already compiled. And then we got this test contract.py, which is a copy of this test contract.py, which I actually downloaded from City of Zion and just made some edits. And then there's another withdraw test.py, which is another smart contract file. So we're going to start with the simple one, which is the one that I edited, the underscore test contract.py. So we're going to go ahead and open that up. Go ahead and move this out the way. Let me make this full screen. Actually, I don't want to do that because I need to be able to see the chat. Let's just do this. The chat right here. All right, you guys can still see this, right? So, as you can see, you know, we have most of these imports, honestly, don't need for this example, but you know, we're pulling in from the Neo BOA library. So boa.blockchain.vm.neo, and then all these classes. You know, you have to notify, the get trigger, the check witness, register action verification, invocation transfer, get executing hash, script hash, you know, storage, everything that you would need to do like a full-fledged contract if you're trying to do something really complicated. But the example that I'm doing here, if you check down in this def main, is actually it's pretty simple. So what I'm doing here, can I make the text larger? Yeah, I got you. That good? So here in the old eyes. So here in our main function, and everything's going to basically happen in this def main function for your smart contracts. What I'm doing here is this is a public key for the wallet that I've downloaded using the NeoPython, or my bad, the NeoPrivNet with gas. And I'll show you where I got that in a second. But this is the public key for that wallet, okay? And I'm storing it in a byte array. So basically, what this contract is doing is that whoever calls this contract, check to see if the person who's calling the contract is the owner. That's what this check witness function does, and that's a built-in function in the Neo library. So we're checking the person who is calling the contract to see if they are if they have this public key, and if it's the owner of that particular wallet. And if this result is true, then we say that the owner is the one calling the contract, return true. Otherwise, return false. Pretty simple. I mean, if I gotta explain that in any more depth, you know, let me know right now before I go on. But I wanted to start with very, very, very simple contracts, and you know, over the next few weeks, I'm actually thinking about, you know, doing more incrementally advanced contracts. So I just want to start off now getting you guys used to the concept of what a contract is. So yeah, returns true, returns false. And we're going to go ahead and exit this because we're not going to do anything extra. I'll go ahead and show you some of like the more advanced ones, just so you can see like some of the stuff that you can do. So, you know, you can put the owner's asset, you can put a Neo asset ID. You can register different actions, you know, withdraw deposits, withdraw reconciles. Does it always have an owner? No, it doesn't always have an owner. You can do whatever you want. You know, the contract can just be, you know, return true, and you know that's a contract as long as you know end up compiling to an AVM file. But for the sake of example, I used one with the owner ID in it. But yeah, this is some, you know, some of these can get really, really complicated. I'm not going to go through everything what all of this is doing, just showing you how complicated and convoluted that some of these contracts can be. Now, all contracts require gas to initiate. So let me, what was it? Yeah, so we're going to call the prompt. So now we're in the Neo Python CLI. In here, if you type in help, you can see all the list of commands that you can do. So I hate this mouse. Gotta get a new mouse. So you know, you can open wallets, you can create wallets, claim gas, migrate, rebuild, yada yada yada. So I already have a wallet, and it is wallet open w1.wallet, I believe. No, okay, hold on. Might just be w1 wallet. It's not wallet open, it's open wallet. And I did have that right. Awesome. So the password, this is a City of Zion wallet. So the password is COZ for City of Zion. And now we open it. So if you just type in wallet, I spent all the gas on this one. Need to re-download. All right, hold on. Let me go ahead and re-download that wallet real quick because we need some gas. Let me just find that command. All right, now let's try that. Oh, and by the way, if you guys are wondering what this prompt.py is, let me just do an ls. That's how you start the Neo CLI. If you could, I hate this mouse. So as you can see, right? Oh my goodness, right? Oh my goodness. All right, we'll get there eventually, I promise. As you can see right here. Anyway, I know oh my gosh. Right there, you can see the prompt.py. So that's how you call it. So we do Python 3 because we use Python 3 prompt.py, and we pass in a flag of -p to tell it we're using the private net. And in the protocol, I don't see this protocol.privnet.json file right here. This is where you would set the information for your private net, which is the information for that Docker container that I referenced earlier in the stream. So I put in the IP address and all that in there. So it's connected to that Docker instance. So we hit the Python 3 prompt.py-p. All right, now let's open up that wallet again. All right, sync balances. Cool. So now you see we have 10 million NEO and we have 17,624 NEO gas. So before, I mean, I know I've already created the A and B file, but I'm going to go back through it again. So we had that test underscore, underscore test contract.py that I showed you, that you're checking the owner and just doing a true or false comparison, right? So now we got to turn that .py file into a .avm file. So to do that, we go into the Python shell again, and we're going to we gotta do an import. So from boa, from boa.compiler, import compiler. Hit enter. So now we've imported the Neo Boa compiler. So then we want to call the compiler.load and save function, and you pass in the path to your Python contract. So in this case, you can see I passed it to the contracts directory / test contract.py. Hit enter, and you know, it shows you this byte string, and we can go ahead and exit it out because we know it's compiled. And if we check, if we check our contracts folder, we see the test contract.avm. So now, my bad. So now we go back. Now, in order to run this contract, let's go ahead and clear this. It's getting messy. All right. In order to run this contract that you have just compiled, you must go back into the prompt.py. Oops. Forgot to do the -p. All right. So let's go ahead and open our wallet again. All right. Now we will call, in order to run the contract, you call the import contract function on the CLI. And the syntax for this actually gets pretty tricky because now we're going to be dealing with data types and whatnot. So the syntax is import contract, the path name of the contract. So in my case, it's contract / test contract.avm. We pass it an empty string because there are no command line arguments. We pass in 0, 1 because we are expecting a true or false statement. Okay. And then we pass false and false because we don't need storage, and we don't need, what's the third parameter? What is the third parameter? I can't remember what the third parameter is. Let's see. Yeah, we need, I can't remember what that third parameter is, but I know the fourth one is storage, and we don't need storage. So import contract, contract / test contract.avm. We're not passing any arguments. We're expecting a true or false return statement. And we don't need any of the other two parameters because we're not using storage or anything else. So please fill out the following contract details: contract name, owner, test, contract. And then we're just gonna hit enter for the version, enter for the author, enter for the email, enter for the description. And enter your password. Enter your password to continue to deploy this contract. So as you can see, before I put in the password, let me just show you what happened. So this is the hash of the contract. Return type is a Boolean, true or false. No parameters. And this is in test. The event popped off in test mode. Smart contract execution.success. So it did. So it's able to run. It used 100 gas. So it used 100 gas in order to deploy. So the deploy invoke was successful. It did 11 operations. Contract state, yada, 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 deployed, gas costs 90. There was no TX fee. So let's enter our password for the wallet. And could not find verification. Verifying transaction. So let me, I'm trouble reading this. All right. To continue for his contract, could not find transaction for hash. Maybe I put in the wrong hash. Hold on 1 second. Or actually, no. Wallet. Oh, there was all my gas. Gonna have to re-download that, I suppose. Ah, yeah. I had the wrong public key. All right, let me go ahead and because I used all my gas. So let me go ahead and just re-download this wallet real quick. It'll take all of 2 seconds. And no, I don't need to do that. I need to, there we go. It's curl wallet. All right. Now let me go back in here. Open wallet, COZ, wallet. Balances. Okay. All right. So let me get this public key. Move this out the way so I can get it. I'm going to copy that. All right. Let's exit out of here. Nano contracts underscore test contract.py. Oops. All right, let's try that one. I always forget to do that. All right, let's try that one more time. I'm going to do the Python 3. Wallet. Okay. All right, so what I'm also going to do is I'm going to do wallet. Make a new wallet. I'm gonna make a new wallet so you see what happens when another wallet tries to call the contract. All right, create wallet w2.wallet. COZ. That at least 10 characters long. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. All right. So as you can see, we have but there's the public key for this one right here. They have no contract does not this shit. I don't know why that's, I don't know what that's talking about. Okay. Percent sync 0, height 0, yada yada. All right, so and then we're gonna send some gas from the wallet 1 to wallet 2. To do that, wallet. Bear with me. Stuff makes my eyes hurt. Delete, address, unspent, close, withdraw, send. Okay. Let's see, send gas. And what was that address? Send gas to this address. We want 100. And we want the from address to be sufficient funds. Insufficient funds. Okay, let me do this. Open wallet. W1.wallet. Wallet. Okay. Why does it say I have insufficient funds? I did something wrong there, and did something wrong. But what did I put in there wrong? Bear with me a quick second, because I want to show you. I want to show you what happens when you call this contract with someone who isn't the owner. Okay. Let's do Neo Python see this. Do create yada 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 yada. Okay. Do please open the wallet. Okay. Well, I don't even know if it'll let me. Let's see. Let's see what happens. Open wallet. W2.wallet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And then let's contract name. Using the password. Dynamic invoke equals false. Wait, did I have the which wallet did I have open? Storage false. Oh, dynamic invoke. That's what that third parameter means. Dynamic invoke. We set that to false because we want to do manual invocation because we're doing a test. That's what it was. So dynamic invoke and storage. Okay, code, parameters, the hash, that all looks right. Self-contract properties, that looks right. This one's for asset ID. Okay. Yeah, okay. That's what I thought. I couldn't call it because I didn't have any gas on this wallet. Yeah. So I mean, long story short, there's still some rough around the edginess with the Python. They're still not all the way there like what it is with C#. But I refuse to touch .NET with a 10-foot pole. So I wasn't going to do a .NET tutorial. And their JavaScript stuff, sadly, you have to build off .NET bindings in order to use it. So I can't use like Node.js right now anyway. And then as far as Golang, they're still working on Golang. So that, that'll be done whenever it's done. And then I think they do have a Java version, but more people are moving over to Kotlin instead of Java. So I wasn't gonna. I feel like Python was the natural choice. I mean, that's essentially it. As far as like how to build and deploy. Let's look at some of these other contracts so we can just see some of the different functionality. Nano withdrawal test.py owner do withdrawal test. Withdraw. If it's not the owner, we need to verify things. We'll test can withdraw neo, notify can withdraw, application. Sorry guys, I'm reading out loud before I just go in and start explaining stuff. Make sure I'm got this right. No matter what happens, you reconcile balances. Someone else gonna make withdraw. Blah 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 blah. Okay. Balances, deposit. All right. So this is a withdrawal test contract. So once again, at the top here, we have the owner ID, which I need to replace with the one in my wallet one or w1.wallet file. We have a Neo asset ID, which is some, I'm assuming some NEP2 or NEP5 token. And then basically you're testing whether you can withdraw or not. So if you are the owner, a do withdrawal test, and we trigger, and you know, we do a verification to see if the owner is the person calling the contract is the owner of that wallet. If they are the owner, then they're allowed to withdraw, so return true. Else, you need to verify a few things. Can they withdraw Neo? If they can withdraw Neo, then return, can withdraw, which will return true. And the I don't know the specific, because this was a test file that I just downloaded before I started the stream. I don't know what constitutes in this particular contract whether or not that person who's not the owner can withdraw or not. Reconcile balances. No matter what happens, we need to reconcile balances. So if, for example, someone has successfully made a withdrawal, the verification portion of this contract checked it all out, but the application part of the contract needs to sync the balance. We don't really care what operation is called. No matter what, we will try to reconcile. Okay, so it does some reconciliation of balances. And then they're obviously taking some arguments. And if the argument is, if the argument that was passed was a deposit, then you deposit the Neo, else you cannot deposit or withdraw. So I don't know if you guys understand what this reconciliation of balance is. So so someone made a successful withdrawal and the contract verified it. But the application part still needs to sync the balance. So you might have to deposit or withdraw. Else, if the operation was getting the balance of, then you're just returning the balance of that wallet. So obviously when you call this contract, you're gonna pass in some command line arguments, whether you're gonna do withdrawal or you're gonna do a check balance, kind of like just like an ATM. Yeah, I guess it's like a little ATM contract. You can call it that. And my mouse is acting haywire again. We check the receiver, adder, and amount. Yeah, I'm not gonna go through every single one of these, but essentially this is just like a ATM contract. You know, you're seeing if they're able to withdraw or if they check their balance or deposit. To me, it seems like it was a very convoluted way of going about it, but you know, more power to them for doing it this way. But let's compile this one real quick, because I'm actually interested to see how this works. Python 3. Draw test up. Most recent call. Let's see. No such file directed. Oh, I was already in the contracts folder. All right, so let's exit out of this. Do that every time. Now let's go back into the prompt. And let's open up our wallet one again. Let's go to import. Withdraw. Test.avm. Let's say deposit. So we got LS. Okay, that is, I swear that's what I put. Okay. Sorry about that. Oh, because I'm already in the contracts order. Contract property 0, please on name. Withdraw. Contract state. Go ahead and do that. Okay. All right, now that all looks right. So let's go ahead and put in our password. Could not find transaction for hash. Verifying transaction. Relay transaction. So this actually did what it's supposed to do, because I did not put the hash for the wallet, that the w1.wallet. So this contract did not go through because it doesn't know who I am, and I have nobody who has given me permission to withdraw from this Neo asset ID that was in the withdraw test.py. Is any of this making sense? And if not, do you have questions? Because, you know, I'm free to answer questions. But yeah, could not get a count or votes, not supported. Is there an underlying gas cost for every transaction outside of the specified amount with the smart contract? The contract was 90 gas, but the total amount used was 100 gas. Yeah, so I want to say on the, when you put something on the main net, don't quote me, and I will double check, and I'll let you guys know on Saturday's meeting, but I'm very positive that you got to have 500 gas just to put out your contract. And then the amount of gas that is actually used on the contract depends on the implementation of the contract. But we're also using the private net, so things are, you know, more rounded up or whatnot, if that makes sense. So like on a mainnet contract, you know, you'll probably use like, I don't know, 0.01 gas. But on average, you know, it like I said, it depends on the contract. You might have a contract that might end up using 100 gas, and that, what is the price of gas right now anyway? Let me look that up, because now I'm thinking about 100 gas is expensive as hell. Let's see. Gas is, as soon as it will. Gas is $37.74 right now. So in this example, you know, that would have cost like $3,700. 37.74 just to call a contract. So, you know, obviously this isn't analogous to what's going to be happening in the real world because it's all on the private net. You have any more questions? Do you guys want me to go? Do you guys want me to go in depth a little more on how to get the environment started? So if you guys want to get started with that, or will you be comfortable just watching a YouTube video? Some of the guys, you know, the reason why I say YouTube is because they go through the different platforms. Like I'm a Linux/Mac guy. So, you know, I don't have any Windows stuff, and the vast majority of them were for Windows. So, you know, I had to basically do a lot of reading of documentation. But, you know, if you guys, is everyone here familiar? Everyone in here is familiar with Docker, right? You're familiar with Docker, familiar with virtual environments with Python. I guess I should stop this contract, huh? Yeah, that contract was still going, so I just stopped it. What was I saying? Yeah, Docker. I mean, you don't have to use Docker. You can do everything on your local instance on your computer. I would not recommend it because like using Docker or using a virtual machine, you're isolating all those stuff. So, you know, you won't actually mess up your machine. I've done that. But before I started, you know, using Docker and other virtualization tools, I messed up my machine quite a lot. Just, you know, having to just dealing with dependencies. So, like I said, that'll definitely help. But while I guess, you know, before I get off, let's go over some of the sample file. So I'm on the NeoBoa. All right. So here's some of the stuff you can do with your smart contracts. You can do what's called, can we run this only with VMs? If so, would it be possible to distribute a VM for us so we can upload to our own personal machines? Yeah, I've actually thought about that. I'm making a Vagrant file. I'll probably won't have it done for another week or so, but it'll definitely be done by the time we actually start doing the Jarvis development. But yeah, I am gonna put out a Vagrant box so everybody can download the VM and everything will already be it'll already be packaged in the VM. Cool. So one of the things you can do when these smart contracts are interops, you know, operations basically on the blockchain, and so this is some of the stuff you can use for gathering state data contained within the blockchain. So for example, right, you can do get account, you can get asset, you can get the block, you can get a specific contract, you can get the header of a height or hash, you can get the height of the current height of the blockchain. You know, get transaction, get validators. For example, one of the first contracts that I wrote as a little test thing was I got the block height and whatever, you know, depending on the block height, if the timestamp was, what I do was like, if the timestamp on the block was divisible by 3, You know, I did a modulus division 3 equals 0. So, you know, if the timestamp is divisible by 3, then you know, return true. So you pass the contract. Otherwise, otherwise it fails. And then I want to do stuff like, you know, maybe, you know, if you invoke the contract and it's you invoke it when it's during a time where the timestamp is divisible by 3, you'll get 1 neo or something like that. You know, so just something really stupid, simple. And there's another thing too. You do not have to do strictly blockchain related stuff in your contract. Like, for example, if you need to do a REST call to a third party API, my uncle in the Bay Area, he said he had an idea for his stepson, you know, basically using the Neo blockchain, and they'll be able to check his grades. You know, a lot they have tools or whatnot, so you can like see your kids' grades and how they're doing and whatnot, and you can get that data back. So the Neo contract would check the status of his grades to determine, you know, whether or not he could get an award based off his grades using the blockchain. So it's and I think he was like paying him per grades. So like if he gets a certain grade, then he puts Neo in his wallet. I'm pretty sure that's what he wanted to do or something like that. So I mean, it's really about, I mean, writing the contract itself isn't difficult. It's mostly about the integrity of the contract, the feasibility of the contract, and the efficiency of the contract, because you do have to use gas to fund it. So, you know, a poorly written contract, and like I said, I think you got to have 500 gas to put your contract out. I can find that out real quick, actually. What is the minimum amount of gas to smart contract? Yeah, I'm not about to comb all that to find it, but I'm pretty sure it's 500, or it might be 100. I don't know. It's something hundred. To put it up there. Yeah, I'll get sidetracked and try to find it. Be sitting up here looking dumb for an hour. But yeah, I mean, this is something that, you know, we think about, especially if we want to do consensus nodes. I know Charles was talking to the Finbushi Capital guys, and possibly getting us a consensus node, which that would bring in some nice little residual income for us to fund some of what we're doing. So yeah, I mean, let's check it out. Go, like I said, City of Zion. They were at the Neo DevCon. I think they have 5 consensus nodes right now. Victor could clarify. I'm pretty sure they got 5. But yeah, they're like the biggest community for Neo. Pretty cool. They run competitions and little hackathons and stuff all the time. But if you head over to their GitHub, it's just github.com/City of Zion. You know, they have the Neon Wallet, Neon JS, some JavaScript application for interacting with the blockchain, Neo Scan, Neo Python, and another Neo JS, and this is Neon JS. I'm sorry. Dang, they got 56 repositories. Yeah, so just check them out. And then more specifically, okay. Oh, update 10 hours ago. Neo Neo Go. All right, cool. Looks like they're making some headway with the Go SDK. That's cool. And you can look at the commit history. You see, you know, the NeoPython, NeoScanner. I don't. It says this was forked and it was updated 10 hours ago. So I don't know if this just happened, but there's a spike of activity there for the Neo Go. Python Smart Contract Workshop updated 11 hours ago. Well, I'll be damned. If I had known that, I would have used that. All right, well, cool. Let's look at this. What is this up over here? Yeah. Set up NeoPython and NeoPriveNet Docker. That's exactly what I said to do. First smart contract using print, runtime log, runtime notify. Use NeoPython's build command, test argument. Build a smart contract using storage. That was the next talk I wanted to do, was doing the smart contract with storage, because that's definitely more complicated. Domain registration, smart contract. Yeah. Next ICO template. Just go ahead and just put that in another tab. We'll look at that in a minute. Recommended setup Linux or Mac is recommended. Yeah, so for all my Windows guys, I mean, if you want to stick with, if you want to do the C# route, you know, more power to you. But otherwise, you know, get a VM. Ooh. Oh, that's right. If you're on Windows 10, you could use the Linux subsystem. Clone NeoPython. Okay. All right. You know what? I'm gonna go ahead and fork this. That's what I'm gonna do. All right, go ahead and hit that fork button. Put that in the DU crypto. So everybody who is in the DU crypto group, I just forked that, so you can check that out. And I'm also going to fork. I'm also going to fork the NeoPython and NeoBoa. Updated an hour ago. Good to see that they're working on this. They're pushing. All right. And 91 commits. Let's go fork this one as well. Put that in DU crypto. Give feedback. Add team collaboration. City of Zion. And then NeoPython. NeoPython fork. All right, well, cool. Well, I did tell you guys to go to YouTube, but now I'm just going to tell you to go to the GitHub, go to the DU Crypto GitHub, and head over to the Python Smart Contract Workshop, and follow the setup for NeoPython and the NeoPriveNet Docker, which, yep, that's the same one, the Metacris NeoPriveNet with gas that I showed you earlier in the video. I really wish I had known that was there yesterday. I would have put that on the Facebook. Would have had you guys go ahead and download that. But like I said, that was a beast to set up without, you know, when I had to hop from video to video. So I'm glad we did find that though. Oh, and there's also some NeoBoa examples. Let's look at this. Oh, okay, that's the same one. But if you download NeoBoa in the test folder, you have a whole bunch of test contracts, you know, adding, appending, doing array arguments, simple stuff that doesn't really do, it's not doing anything useful, just getting you in the mindset of building, you know, binary operation, block test, byte array, comparison test, concatenation test, equality test, event test. They even got some Fibonacci stuff on here. You know, like I said, not little nonsensical apps. If you've coded before, I mean, it's the same thing. It's just logic. Yeah, make function, lambda test. Like, I don't even know why you wouldn't even would put some of these in a smart contract, other than for the sake of just, you know, teaching, I guess. So, do we have any other questions? Any in-depth questions I can answer? I'll be glad to answer. And also, feel free to raise your hand, guys. Feel free to raise your hand and ask questions. I got a question for you for the next video. Is there a contract or a subject matter you would want me to write that, you know, that's not comparing the owner, you know, something that's not, you know, too complicated, but I don't know, something that'd be fun and interesting. You just let me know and I'll write it. Anybody? Ideas? I mean, you could also throw them out on the Facebook group, so it doesn't really matter to me. But yeah, I mean, I'm a feedback kind of person, so I'll do whatever you guys want me to do, if that would help you learn. So you just let me know. But I think I pretty much covered the basics. So let me just reiterate. No ideas yet. Installing dev environment now on Windows 10. Awesome. Cool. So if you run into any issues on there, just go to the GitHub and click on the, or it'll tell you, what is it, installation, platform specific instructions. There you go. Yeah, so and then I think it's the same thing for the Neo Boa as well. Yeah, so it'll tell you if you need anything. Open question. What is the website Git? Oh, you mean Git, GIT, like GitHub? This is a website where code is hosted and managed. So you're working on a project, and there's the thing, Git can be used for any kind of file. You know, I know graphic designers. GitHub, GITHUB. I'm gonna go ahead and just put that in here. All right. So GitHub is a website where you can put your code up. So like I said, you don't have to just do code. I know some graphic designers, and they put their photos in Git. And so when they do like their first draft, second draft, yada yada yada. I know some people who write books and keep their they put their books and stuff on there. Ola Juwan, how can I contact you directly? Facebook or any other social media? All right, my phone number is open to the world, 859-402-4863. You can also send me an email at inquiries@JyroneParker.com, and I'll put that in the message box right now. So this is my email. And here's my phone number. Anybody's welcome to call. Now, don't call me at no crazy times. If you call me at like 2 o'clock in the morning, I can't guarantee I might not cut you out. But, you know, reasonable times, yeah. You can always call me. What time zone? I'm in Eastern Standard. So right now it is 7:28 p.m. where I'm at. Although I do a lot of traveling, so you might catch me on the West Coast. Yes, Justin, thank you for that uploading my YouTube. That is my YouTube page. Appreciate it. Vivian said, thank you very much. Okay, I'm glad I answered your GitHub question. Any other questions before I just do a quick recap? And ask you guys, I mean, we can do, what's today? Today's Wednesday, right? I can do next Wednesday for if you guys give me a topic for a smart contract. You know, now as you had this, you saw the basics. Give you a week to, you know, get your environments together and play around with some of these, you know, simple little baby test contracts. If you guys let me know give me at least 5 days. So if you let me know by Friday, you know, what kind of a contract you want me to write, I'll make sure I have that done for next Wednesday. We'll talk some more of the advanced stuff like the execution engine, and some of the other interops that we can do. Lynn Mosley, thank you, brother. Thank you. Appreciate all of you guys who are watching. Appreciate the questions. Yeah, you guys help me get over my social anxiety. What about multi-user contracts that embed binary files, PDFs, etc.? Yeah, so that's where like that storage comes into play. And you know, you can definitely you can store all that stuff on the block. That's expert level. So, you know, I want to do something that's before that, and then we can do the multi-user contracts in like the 3rd or 4th video probably. I wouldn't feel comfortable doing that next week. I don't feel like enough people would have had enough time to read the documentation and stuff and really take a grasp, have a strong grasp on it. But that is a very good point. And I did plan on later down the line doing a multi-user contract. So, all right, to recap, smart contracts are programs that are run on the Neo blockchain. They use gas to run them, and they can be written in multiple languages and C#. They have the Python library. They're currently working on the Go, and I want to say I saw a Ruby library too. Yep. So they're working on a Ruby, they're working on Go, JavaScript, Java, Python, C#. Yeah, right here. JavaScript, Python, C#, Ruby, and Go. Right now, the C# and the Python are the two that are the most complete. C# being the number 1, Python being the 2nd. When you write a contract and you're using, and I'm only talking about Python because that's what I just got done doing. You have to convert that Python script or whatever script, even C# or whatnot. You have to compile that down to AVM code, which stands for Shared Virtual Machine, even though they renamed it to Neo. and that compiles it basically into bytecode. Neo VM bytecode. That bytecode is then in turn run on the Neo Python command line program, and you give it a wallet, you run the contract, you pay the gas, and you let it do what it do. That's the high level 1, 2, 3 overview on how it goes. I hope I did a good job explaining. I hope I didn't confuse you. Hope you're less confused, not more confused. If you are more confused, I wouldn't want to get off the stream. So please let me know before I end the stream if I need to clarify something before we head on to day 2. Because I'm pretty much expecting you guys to go ahead and take the initiative to get your environments together, so that when we start next Wednesday, it can be a coding along session. I just know you guys didn't want to be on the stream with me for like 3 hours setting up Docker and all that good stuff. So we're all adults here, putting the responsibility on you guys to be ready for next Wednesday. Like I said, my contact information is always open. You can always hit me up on Facebook. You can call me or you can email me. Once again, my phone number is 859-402-4863. And my email is inquiries@JyroneParker.com. So I'll give you the last 30 seconds to ask me questions. And after that, I'm just gonna go ahead and end the stream. So we'll leave it to you guys while I twiddle my thumbs for 30 seconds and answer these questions. You are welcome, Miss Lisa. Ain't no problem. Ain't no problem. Let's see. Some other stuff that awesome Neo resource for working with the Neo blockchain. What's this? Yeah. Yeah. Okay, I'm gonna fork this too. I just forked the awesome Neo repo, which is just a list of resources, white papers, blockchain bootstrap files, some more information about City of Zion, some code examples, some dApps, exchanges, merchandise, SDKs, smart contracts, blog posts about how smart contracts are priced. All right, that's a good one. Yeah, head over to the GitHub and read that. This is some really good information. Let's see, look at this. Okay. Here's all the fees for system calls. Asset create 5,000 gas. God bless America. That's a lot of gas. Okay, the default is 0.001. Additional to 1 gas minimum. 5,000 gas? Yeah, they just don't want people to over messing around. Okay, and fees for instructions. Okay. Damn, that's expensive. All right, but all right, guys. I think that's it. I'll have Charles and them set up a Zoom for me for next Wednesday. Sorry, I was a little late. I didn't have access to actually start the stream, so we had to, you know, have Lawrence help me out. So we'll make sure that won't happen again next week. And 6 o'clock p.m. good for you guys? We want to do later or earlier? Probably can't do earlier. Let's see. Ola raised his hand. All right. Let's see. Attendees. Hold on 1 second, Ola. Can you hear me? Yeah, it says talking permitted. Unmute yourself. I'm hitting unmute. Hold on 1 second. I don't know what's going on. I keep hitting unmute. Ola, I think you might need to unmute yourself, brother. I'm gonna remove you and try it again. Make sure it ain't on my end. There you go. Okay. Well, Ola, if you want to try to come back, I don't know where you went, but sorry about that. Oh, you there? And I don't even see a microphone for you now. I don't know if you like need to plug in your headset or something, but it's not even showing. It's not even showing a microphone for you. This is awkward. Let's see. And roll back to an attendee. Well, brother, I honestly I don't know what's going on. It says you're permitted to talk, and I can't hear you. So we might have to. You might just have to hit me up on Facebook chat if that's all right with you. Sorry about that. I'm going to go ahead and just remove. Yeah, I don't know. I don't know what's going on there. I really don't, brother. I'm sorry. But just hit me up on the Facebook chat, and I'll respond directly to you. But yeah, my last question before I get off here is 6 o'clock Eastern Standard Time PM. Good for everybody next Wednesday. I'm going to assume that's a yes then. As the earliest for me because traffic. Okay. Okay. I mean, I can also do 6:30. I almost said 6:30 instead of 6 because I know people get off work at 5 and sometimes might take them like at most an hour to get home. So I don't mind doing 6:30. I can even do 7. It's just, you know, whatever the vast majority of you guys want, and that's what I'll do. But I think that's about it. I would prefer 6:30. This is Brian Jones, by the way. Hey, Brian. Any of those are good. Okay, let's do 6:30 then. So next Wednesday, 6:30. Have your environments ready. If you are struggling, hit me up sooner rather than later, and I'll set aside some time to help you. And then yeah, have everything ready by next Wednesday, and we'll do some more smart contract development that'll actually like be meaningful. So you guys send me your ideas for contracts, and I'll choose the best one, and we'll write it out on Wednesday. But appreciate you guys. Holla Black.